that is too limited a viewpoint. And as a result of that, the London Science Museum a couple of years ago started talking about a concept called science capital, where you actually sort of enlarge your viewpoint from science education to something like science connectedness. And I think that is an important thing to think about. And now my question would be, so how does science capital relate to science culture? The short answer is, I don't know. I think they are very similar to some extent. But I think that when it comes to science, whether it's science capital or science culture, we have a lot of evidence and data around the world to show that science centers do have an influence on people's attitudes. And I think that is actually the most important impact of a science museum or a science center, that it influences people's attitudes towards science, the way people think about science. In addition to that, we know from research that science centers, they strengthen science learning, they enhance an interest in science, they strengthen motivation to learn science, they affect attitudes, as I said, they increase confidence in science, and they influence career choices of young people. All of these are very important aspects. Of course, we have some data on the career choices in a more general statistical way, but of course, I guess all of us have a lot of anecdotal evidence where we have people who have made a career in science later saying that actually when they were a young boy or a young girl and they visited a science museum, that's where they got sort of inspired for their career. One example is the Nobel laureate for chemistry, Sir Harold Kroto, who visited Heureka at one point. And I always remember the point he made, that when he was a young boy, he went to the science gallery at the Science Museum in London, and that's where he got his inspiration. And then he went on to a career in science and then to receive a Nobel Prize. However, the important thing is not for us to produce Nobel laureates. The important thing for us is, of course, to help people understand how they can use science in their everyday life. And I think we actually are doing that to some extent. We are pretty good at talking about basic science and sort of getting people hooked onto that kind of thinking and sort of that people understand why science is needed. But I would like to pose the question, when it comes to more complex issues, are we as good? I'm afraid we are not. The world is dominated today by what we call the wicked problems. And those are, of course, always, they have a base in science, but science alone cannot solve those problems. There are economic, there are political, social issues involved. And even if science is providing like a base information, that the problem is much, much more complex. I think one of the most important things that we can do in that context is to provide people with an understanding on how science works and what the nature of scientific knowledge is. I think of science as a revolutionary process because it actually proceeds through paradigm shifts. And now you need to understand that this is a very tricky area because, of course, when you have a certain concept, a certain scientific theory, and you have the majority of the scientists working in that field adhering to that theory, it is a very strong base, and usually there's a lot of evidence in favor of that concept. But still, there might be a case that suddenly there is new information, new data available, which will sort of question that concept. And that will always be a revolutionary thing because all the people who have a position in science, they adhere to the existing paradigm. And then there is somebody, usually a young guy, coming up with a new thinking. And of course, that is very difficult to actually get that through. And that is why the rules of science say that we should have an open and critical scientific debate. It's very important that it's open and critical. I am a little bit suspicious that this may not always be the case. I have evidence that that I know there are cases where it absolutely has not been the case. And in a way, it is understandable, because if you have your position because of the science you have done, and then somebody questions the fundament of that, of course, it will affect your position. And it's very human to try to stop that kind of debate. But in science, that should not be allowed. In science, it should be an open debate. And I'm questioning whether we actually are able to provide people with a realistic concept on how science works and what the nature of scientific knowledge is. I think it is important because most people tend to think about science as the truth. It's sort of, that is the truth, and we just need to adhere to that. But science is never at the truth. It can approach the truth, but I don't think it will ever actually get there. And it's important to understand that science is not decided by voting. You sometimes, when you read about the current debate on climate change, for instance, you sometimes read statements in the press like 97% of all scientists working in the field think that climate change is human caused and all that. Actually, from a scientific point of view, that kind of statement is more or less bullshit, because you don't decide scientific issues by voting. They are decided by data, by facts. And it is enough to have one voice, which actually is different. And if that voice carries the data, that will cause the paradigm to be shifted, then that will be the case. And the history of science actually has many examples where exactly this has happened. So I think this kind of understanding more deeply what the nature of the scientific process is, I think that needs to be part of the agenda that science centers and science museums have. And as I said, I am afraid that we have been very good at conveying basic science and basic concepts, but we have not been equally good at conveying the more complex issues. Thank you.
Thank you. That was Professor Edvin Persson, who is an independent consultant advising science centers and museums on core crystallization, strategic morphing, and institutional evaluations. He was formerly director of the Heureka, the Finnish Science Center, and during his leadership, the center in Heureka achieved international reputation for its circulating exhibitions. 25 countries, which traveled to 25 countries in 4 continents. He was president of international branch of the organization called ASCC, the Association of Science and Technology Centers, from 2004 to 2005, and also of the EXCITE, the European Conference on Science and Industry, from 97 to 98, and he's now honorary fellow of these 2 organizations. His special interest regarding Science Center has been about their impact, which I know there's a report which he was the author. We always follow that report on impact of science centers, on which he has published separate papers. His company is worldwide agent for the Dinosaurio Mexico, prime producer of robotic dinosaurs exhibitions. I'm sure those dinosaurs are available. Now we have Sherman Rosenfeld, who's from Weizmann Institute of Israel. Can I request Sherman to share his views on the topic and also your perspective of the science centers and their impact on society?
Yes, thank you very much for the introduction. I would like to have the screen. Is it possible to share the screen?
You can share that.
I have a
PowerPoint.
A PowerPoint, yes.
Can you click on the share screen?
Okay, so I will share it. Yeah. There you go.
And then you see, yeah.
Yeah, okay, so you can see the PowerPoint?
It's coming.
Okay. Okay, so thank you for the introduction, Ganja. So I want to talk about developing cultures of science in science museums and elsewhere. First of all, happy birthday to Saroj Ghosh, and also speedy recovery. A little bit background about myself. I was born in Los Angeles, California. In 1982, I came to Israel, and I've been there ever since at the Weizmann Institute of Science. My expertise is the area of informal science education and its connection to formal science education. And what I want to talk about is how I have tried as a museum director in California, who worked with the Lawrence Hall of Science, the Exploratorium, other places, how I took these ideas and tried to bring them into the classroom, because I would make an argument that it's important for us to broaden our perspective and look at science culture as something that can be done in museums and also with other partners. So I think the first thing I'd like to talk about are what are cultures of science and technology? Notice the plural. I don't think there is one culture. I think there are many. I think in a way, each different discipline has its own culture. There is something that connects them all, but there still are differences, just like with people. And I also want to mention that we're talking about science and technology, not just about science. So I would say that cultures like this are environments that actively and proactively promote the transformation of questions about the natural world into answers, and human problems involving the natural world into solutions. There are two important claims. I think this is what I see as the cultures of science and technology. We start with questions about the natural world and turn them into answers, and that's called scientific research. But we also have human problems about the natural world we want to turn into solutions, and we call that technology. And that's what we talk about R&D, research and development. So having understood that, what are the requirements that we have for developing these cultures? I would argue that they're all about key values. And the values are, first of all, curiosity and question asking, honesty, openness. Professor Persson talked about that. Data-driven argumentation. Ganja talked about that as well, and how we have to be connected to data. And I add this, a maker's mindset. Today, making is taking over the world, and I think rightfully so. It's a wonderful addition to science and technology. And a maker's mindset is basically a mindset that says, I don't know yet, but I'm going to keep on trying. And the time, space, materials, and people to support these values. Those are the requirements that I would say are needed to develop cultures of science and technology. However, there are some barriers, and very significant barriers. I think that we need to address them. The first is lack of time. The big problem in schools is that we do not develop cultures of science and technology because we don't have time, because we have to cover a lot of stuff. Also, there's a fear of looking dumb. I don't want to show that I don't know. I don't want to ask because somebody might laugh at me. The lack of time, the fear of being dumb, for me, define most of what goes on in school science. And what I would claim is most of what goes on and passes for school science is not about developing the culture of science. It's about getting people through a system, and it does not develop scientific culture. There are exceptions, but I think those are two barriers we have to address. A third barrier is a culture of certainty. As long as I know that I'm right, as long as I know that these are the facts, don't question, that's a big barrier to developing a culture of science and technology. And last but not least, what adds it all up together, a lack of appropriate mentors. We need to find people who know how to mentor others, how to give them the opportunity to ask questions, to make mistakes, etc. And they have experience in doing things that are uncertain. I'll give you an example of something that has been published, and it's also in the museum world, and that has to do with the cow's eye dissection. This comes from the Exploratorium. And in the Exploratorium, what do? They take a cow's eye, they take it out, and they dissect it with people. And it's also online. a very fascinating experience. I ran across this article, a research article, and it was about how do you develop early interest in science. And I was surprised to see that the person that was quoted at the beginning, a female PhD student in chemistry, said the following: I was in the 3rd grade. My teacher did something you couldn't do in class anymore. We dissected cow eyes. And I thought it was so cool and so much fun that he sent a bunch of extra eyes home in a bag. It reminded me to put them in the fridge when I got home. And so I did. And when my mom came home and she said, hey, how was your day? I said, great. And I just went about my business and forgot the eyeballs in the fridge. She thought it was leftover lunch and went to open it up. And there were like 4 or 5 eyes looking back at her. And so all of a sudden I heard this screaming and I realized what I had done. And from that point on, I really started to love science. So there's an example of science culture. And I would like to talk to you now about student projects, because I think that's the way that we can develop student interest in culture, of science and technology, in schools and out of schools and every place you want. And I think that there are 3 elements. I've been working in student culture and student projects for like about 20 or 30 years, and these are my insights. I think you need to have a connection between questions, knowledge, and R&D methods. And that's all based around the intrinsic interest of the student, their learning style, and then of course, regular feedback and evaluation. So I want to go through each one at a time. First of all, we need to have different types of questions and people who can ask them and people who feel comfortable about them. You know, different kinds of questions are pretty much like different kinds of elements in the periodic table. You can't talk about chemistry unless you can talk about the elements. And you can't talk about science until you can talk about the questions. And there are different types of questions. This is a whole talk in itself, but I think you get the idea. You know, there's just lots of different questions between, from something like what's going on, what's the connection, how does it work, why is it happening, et cetera, et cetera. The second thing is, and I just want to mention, this is a graph based on real data, and you can see that typically from age 1 until 17, the ability of students to read and to write go up, and the ability of them, or not the ability, but the consequently, the performance of them asking questions goes down drastically. And so I think we need to invest more time into have teaching kids and giving them the permission to ask questions. There's also different types of R&D methods. There are some of them here: experimenting, making models, surveys, observations, building prototypes, etc. And of course, there are different types of knowledge. I think it's important to realize that that combination between those 3 aspects is what makes a good project, makes a good scientific research. And now I want to talk about how do we bridge between formal and informal learning. So Avi Hofstein and I wrote this article in 1996. And afterwards, my student, Orna Falik, and I developed a model on how to implement between formal and informal. So I just want to briefly talk about that. So we would say to bridge the gap between formal and informal learning contexts, you need to have 2 staffs: the formal staff, the informal staff. And you should engage in the intersection of 4 aspects and 4 design principles. So here are the 4 aspects. The 4 aspects are organizational, cognitive, affective, and social environmental. In each one of them in our article, we talk about the big differences between formal and informal institutions. How do they differ? And so I think the 2 groups of people have to really talk about those differences and understand them. And then there are 4 design principles. Mutual recognition of the importance of bridging between these different approaches, mutual acquaintance between the curriculum of different programs, whether it's informal or formal. How do the schools do things? How do science museums do things? Preparation of students to reduce the novelty space. That's basically the aspect that when you go to some place you don't know anything about the physical or the cognitive newness of that area, you're going to spend more time on that newness and less on the actual knowledge acquisition. So we need to prepare students for that. An ongoing dialogue between the 2 groups. This is a visual graphic of the design principles and the aspects. The original article has examples on how this can be used. We've used this successfully in bridging between formal and informal. And finally, where can we develop the cultures of science? And here you see lots of different places. It's not just science museums, it's citizen science, it's science journalism, it's new media, it's science competitions, science festivals, science fairs, hobbies, you name it. And I'll just mention that my colleague Judy Diamond and I are now writing a book on the state of the art of informal science learning, where we have examples of all this. We'll have about 40 different chapters from people from around the world. And we're exploring the state of the art of this whole topic on developing the cultures of science. So I want to just end with a Happy New Year. This is the Jewish New Year, Rosh Hashanah. It's starting this coming week. So I wish you all a sweet, joyful, inspiring, meaningful, fun, and happy and healthy New Year. That comes right from Rehovot. And I want to mention the memory of Watson Lech. Many of you know him. He was a great friend and fan and colleague of Saroj, and we miss him deeply. Thank you very much.
Thank you, Sherman. I just give a little introduction of you now because you have spoken. Sherman Rosenfeld received a PhD in biology and science education at the University of California in Berkeley under the mentorship of Professor Mike Lech, whose photographs he just showed you. In fact, Dr. Mike Lech, who later became Vice Chancellor of the Berkeley University, was a great friend of Dr. Saroj Ghosh. And I remember having visited Mike Lech's house with Dr. Ghosh in 1983 when we visited Lawrence Hall of Science. Since 1982, Sherman has worked as a science educator and researcher at the Weizmann Institute of Science in Israel and internationally. He served as a director of a science center in California and as the educational director of the Weizmann Institute's outdoor science center, the Garden of Science. He directed Israel's informal science education program for the youth, spearheaded the introduction of project-based learning into Israel's middle school science and technology curriculum, and participated in multinational projects funded by European Union. He is currently co-editing a book on the state of the art in informal science learning with Judy Diamond, planned for publication by Routledge in November 2022. I'm going to be associated with Weizmann, with Sherman for this book, if possible. And thank you very much for your nice insight into culture of science and the ways to develop the culture of science, especially young children. Thank you very much. Now we have with us Mr. S.M. Khened, our ex-colleague in the National Council of Science Museums, an electronics engineer by training and science communication by vocation. He has served the Science Center field for more than 33 years. He recently retired as the director of the Nehru Science Center in Mumbai. He held the position of directors of 3 large science centers in India, the Vishwesvaraya Industrial and Technical Museum in Bangalore, National Science Center in Delhi, and the National Nehru Science Center in Mumbai. And he also held the directorship of the Modern Art Gallery. What a combination of art and science. During his career, he immensely contributed to development of exhibits and science centers. He was very efficient in networking with stakeholders for science and success of science centers. Instrumental in developing an international exhibition on cricket and how the cricketing nations became friendly nations through cricket. And this exhibition became very popular and went to Australia, to England, and to some in India, various parts of India. So now I request Mr. Khened to share his views on the theme of the conference topic, as well as how he feels the science centers have impacted the society at large. Thank you, Mr. Khened.
Yeah. Thank you so very much, and very kind of you for the kind introduction. It was fascinating to listen to my predecessors, Dr. Persson and Dr. Sherman. I know we have assembled today basically as a continuum of a felicitation program that we had done yesterday on the 86th birth anniversary of our mentor, godfather, the founder of the National Council of Science Museum. Yesterday, the whole of the day was concentrated on the foundational values and how the genesis of the science museums and the science centers came about. One thing what was highlighted by Dr. Ghosh yesterday was that when the museums movement started in India, it actually came up as a scientific and industrial research museums, the Birla Industrial and Technological Museum, and then subsequently the Vishweshwara Industrial and Technological Museum, until coming to the Nehru Science Center, where we also begin with, when we are a part of the CSIR, we perhaps approach that the industrial museum, science and industry museum concept, until changing gears to have an open air science park, basically as an influence of the socio-cultural system that existed then. Since when we're talking about the scientific culture, if it has to be enshrined and for a possible dissemination of this, it is mandatory for all of us, the practitioners of science communicators or science museum or science center, that we involve the social scientists, the political scientists, inclusively. Until we involve that, it is not possible for us to we have a tyranny of numbers. We have about 1.3 billion people. Although we are very good at when we aim certain things, we achieve it. Take for example, I think Dr. Jayaraman spoke about it when it all started. The COVID when it started spreading in India. People were worried. All over the Western world were worried. What's going to happen to India? Could be the mass spreaders. But then today, I think Dr. Fonke said 66 crore vaccinations have been given. This has come about primarily because of the will of the social scientists and the political scientists, along with the scientists. The scientific fraternity and the science communication. It's therefore mandatory that for science communication to exist, these things have to work together. And when Dr. Ghosh talked about this talk, I think Dr. Ghosh is a standing example of how to come out of the silos that each one of us presently are working, particularly in India. The science centers or the science museums, I would put it, both of us put together, we work in some kind of a silo. And so is the case with the art, archaeology, and cultural museums. They all work in silos. I think that came about today in the morning session when we had people from the museum fraternity speaking to us. But the beauty is, Dr. Ghosh is an embodiment of how science, art, and culture can fuse together, network together to achieve the best possible result. He's an example. He rose to the level of becoming the president of the ICON. So, to give you one example, what we did to involve people, both in terms of social as well as cultural aspect of it. We are talking about the toilet manifesto, which is going on all around. Toilet is something is kind of a taboo in Indian system. If you really look back, the toilets were actually built outside the house when you had large space. With the shrinkage of the space, you brought the toilet into the houses. What we did in the Nehru Science Center, when we did an exhibition on toilet manifesto. There could be a political manifesto. There could be a science manifesto. Can we have a toilet manifesto? So this is a kind of it's a social subject, having a political connotation, having a social impact. So in the Science Center, in order to create this scientific culture that we are talking about, this scientific culture can be created when we actually involve every stakeholder. Majorly, if you have to touch the larger audience, we got to involve the social scientists, we got to involve the political scientists. This is what we did. There is another exhibition which I vividly remember. Of course, it was not done in the Science Center. It was a beautiful science exhibition, more or less a scientific content, but done in an art exhibition. It was called as a soak. Mumbai, during the rainy seasons, sometimes the whole city goes under water. There's so much of drainage that happens. The water all over the city of Mumbai, the water logging takes place, and the local trains come to a standstill and things like that. So that soak exhibition involving the historical aspects from the British times, the drawings, etc., putting the original drawings and giving a message as to why this is happening. Why is it not, why we are not able to soak the water, why the earth ground is not able to soak this water. So this is a kind of an art come science gets blended into this and very effectively done. There is another thing that I would like to talk here. There's an exhibition on water, the elixir of life. What we did is we had about 2.5 months of time where we involved, there's one of the best art college here in Mumbai. It's called the JJ School of Art, which is about 125 years, 130 years old college of art. We, the Science Museum curators, have our own way of looking at the water from the scientific point of view. What we did, how do the artists look at this problem? That what we are thinking about, all of us are talking about water, what it's the essential of, it's absolutely essential. What's going to happen to the, if there is no water, will the third world war happen because of the water, things like that. You know, artists came out with a completely different connotation than what we as scientists did. When I say scientists, as science curators profession who have been following a certain type of exhibits, what we call as interactive or participatory or minds-on kind of a thing, but they came out with a very abstract ideas. They were as fascinating as what we have done. So there is a possibility for the fusion of these people, all of us, art, archaeology, culture, each one of us coming together to enrich the presentation and to create the scientific culture. Since we are talking about the future also, you know, our own science, NCSM has what is known as a policy for scientific, promotion of the culture of science. In the promotion of the culture of science, there is a certain yardstick that we have defined. Perhaps that yardstick, perhaps at this stage of time, it may need a change. For example, if you have to have a science city, it is specified that we need about 32 acres of land. Or, if you have to have a national science center, you need about 16 acres of land. In the modern times, when the land is shrinking, the value of the land is increasing, is it necessary to have that? Can we have vertical urbanism? For example, in Mumbai, 12 acres of land. There are several people who have told you're sitting on a gold mine. Is it necessary? No. Can the same concept of the science center going vertical, which perhaps is followed in China, where, again, it's densely populated. So there is a different approach that all of us can adopt with the changing times. I will also come to, I think, Persson talked about how Harold Toto was influenced by his visit to the London Science Museum. Similarly, we have several cases here in India. For example, Mashelkar. Mashelkar keeps talking about when he was, I think, class 4 or 5, I don't know. Wherever he talks, he says so. His science teacher actually took him to a soap factory to talk about soap. So this is something where the science centers provide that ambience of coming out of the classroom. So it is not necessary that we also have to find out that one individual who can perhaps be a Croto. For example, Raman looked at light differently than what Rayleigh looked at. Perhaps Raman would not have looked at light differently had he not seen that one board of ambience. That ambience is the Indian Association for Cultivation of Science. That one small board that he looked at maybe changed the whole course of his career. In a similar manner, I personally have a feeling that science centers all across the country have the triggering point. Michael Faraday, for example, had he not listened to the lecture, Humphrey Davis lecture, perhaps things would have been different. Just the lecture that he listened to maybe it excited his mind, and there was a hidden scientist in him to become a Michael Faraday. So similarly, all across the country, the science center have that ambience. It is just that we need to collectively work together with the social scientists, with the political scientists, because we face a tyranny of numbers. We have 1.3 billion people, and then with all that expansion that we have gone about, we've been able to reach about 62 science centers. So we have so much to do. If that so much to do is to happen, we have to engage the social scientists. The classic example, there are still vaccine hesitancy even in the best of, in the most developed countries like US, for example. Australia, there is a lot of vaccine hesitancy. In India, which is because of the social scientists and also the political class coming together, joining hands, that vaccination hesitancy has come down, and we've been able to reach to it.
Just reminder,
Yeah, so I'm just coming to a conclusion. I'll be concluding this. Basically, what I'm trying to tell is learning from, since this is a tributary conference to Saroj Ghosh, I think we should all take an example from Dr. Saroj Ghosh and try and involve all stakeholders and not work in silos. Each of us are working in, when I say each of us, whether it is the practicing scientists who are working in the scientific research laboratories, which are funded by the government. Most of the science research that happens in India is government funded. The scientific, the scientists, the practicing scientists, the science communicators, it could be print, it could be, Vigyan Prasad, when I say about Vigyan Prasad or the art, culture, archaeology, all of us can come together, join hands to be more effectively communicating science and creating the scientific culture that, Mr. Rautela talked about. I know the time is very short. It's a premium for us. I think with this introductory remark, I will thank you.
Thank you very much, Mr. Khened. Now, Walter Staveloz has joined us. So I would like to just say, Walter has over 30 years of experience in science centers, science museum field. He created a science center of the University of Brussels and then became the first executive director of Onsite, European Network of Science Centers and Museums. In that capacity, he obtained various European Union grants, including the Persson, building bridges between informal and formal science education. After more than 10 years, he moved to US to become the Director of International Relations at the Association of Science and Technology Centers that we call ASTC. During his 13 years at ASTC, he created IGLO, International Action on Global Warming, represented the field at the Rio 20 Summit, initiated the International Science Day in partnership with UNESCO. After his career at ASTC, he became an international consultant for science centers and museums worldwide with Yes You Can Consulting Company. He recently became a Fulbright specialist in all matters related to capacity building and strategic planning for science centers and museums. Walter created museumexpert.org group that aims at supporting museum staffers out of the work because of COVID-19 pandemic and to analyze the future of museum careers. What an experience. I would now request Walter to give his viewpoint on the topic as well as what he thinks the role of science centers in spreading the science and diffusing the culture of science. Walter, please.
Thank you so much for this introduction, and happy birthday as well to Saroj, and hope he recovers soon. First of all, I need to echo the words from Pele in the beginning about the composition of the panel, because I have communicated on Facebook about this session and how proud I was to be part of that, and got a lot of remarks from a lot of friends in the field about the composition of the panel. And so I urge NCSM to look into the future, to be more attentive to that and make sure that all voices are heard. So this one thing be sent. Another precaution is we have a short time. And so all what I'm going to say is not nuanced, not very nuanced. It's going to be unilateral and probably a little bit controversial as well at some point, but hopefully that will trigger some conversation. So, but to make sure that there is no misunderstanding, my view about science is that science is like the air that we breathe. We don't see it, we don't notice it. No one cheers when he's breathing, but when it's not there, we die. So that is how important science is for the planet and for us individually. But even if that is so, the science is not, from my point of view, a significant part of what I call the collective consciousness. As much as we want it to be, we have to be very clear about ourselves. We were speaking about the influence that we have on a number of people. I think that we systematically make a mistake by comparing our audiences, people who visit us and people who are captive about science, captive audiences, and we look at them and we don't look at all those who do not come. And so from the point of view of the numbers, we certainly in no way reach the population. And in that regard, from my point of view, there is not a significant impact that we can have on scientific culture. So from my point of view, as I said, scientific culture is an illusion. And there is a long history of a conversation about the relation between science and society, science and culture, for centuries. And over the last century, in the 1950s, 60s, certainly that has come up again in various ways, especially because of the competition between the US and the USSR for exploring space. There was this push that now we need science and technology to make sure that we win that battle. And that led us to some kind of vision about science and science culture that was very strong in the 80s. And I remember typically sentences like the following: it is not acceptable that people know Michael Jackson's latest song and that they even can sing it and know all the words, but they don't know who is the latest Nobel laureate. And so this kind of vision was, we need to go to the public with this idea that everybody should know who the latest Nobel laureate is. And that was part of a culture that at time, recently or 20 years ago, we started to criticize as the deficit model, and where it was like, we need science in society, we need to communicate it, we need to educate people, we put all the efforts behind that. And we know after a while that didn't work. And that has been replaced over time by science, public engagement with science, science and society, science in society, science for society. But however, I think that there is a lot of evidence that that change did not affect or increase the place of science in culture either. So one of the elements that I use for that is that, and especially in the developing countries and in developed countries like Northern Europe or the United States, etc., we have not seemed to be able to make a significant difference in the global numbers of how many kids are interested in going for scientific studies. We have influenced a few, we have influenced individuals, but when we look at the needle globally of the population and not only our visitors and captive audiences, we have not moved that needle. So we have not done either we have not done our work, or there are obstacles. And I think indeed there are subjective and objective reasons why science does not penetrate culture as we would like it to do. And so I'm going to give you a few examples, and bear with me, this is very personal, but it explains a little bit why I think in this way. When Donald Trump lost the election, he refuses to recognize it. And it took 3 weeks for the counting to be finished and finally to be announced that Biden won. It was a Saturday morning. I can remember it. It was just before noon, and I was sitting in my apartment, and suddenly I hear a big noise, and I didn't know what was going on. And I opened my window, and in the patio and on all the balconies around me, people came out of their apartments and were shouting and screaming, and they were chanting and saying, "It's over, it's gone." And I took my phone and I filmed it, and I called my son in Brussels and I said, "This is happening here, this is amazing," and I nearly cried. So this is sort of an emotion that overcome in an event like that. And that is happening, this emotion part, in many elements. Think about the latest soccer final between England and Italy. When England scored the first goal after 2 minutes, the whole stadium exploded in an intense expression of emotion, not only in the stadium, but in front of televisions for millions of people everywhere. And the last example is when I'm listening to Pavarotti and the three tenors singing in Caracalla, Nessun Dorma, which is one of the most beautiful things ever written in music. I can listen to that every time, and every time it moves me in a way that is beyond understanding. So what do I think are the characteristics of that? I think that the emotion part in culture is an extremely important one, and that the intensity of the emotion is important, and also the repetitiveness, it's coming back and back and back again. So I mean, it is, when I listen to Nessun Dorma, every time I can have the same emotion. When my soccer team scores a goal, every time I have an intense reaction to that. So these are things that you do not necessarily find in the scientific learning, in the scientific endeavor, in the research. Individuals, of course, they have that. But think about the men on the moon. Even when the first man on the moon landed, we did not see people going out on the streets and driving their cars and screaming in the streets and things like that. That's not happening. And so, I mean, there is a very big difference between how the population, the global population, expresses themselves and reacts to things that are part of their living world, part of their common consciousness, and science is a sort of an obscure part of that, not for everybody, but for the majority of people. So we can associate ourselves with cultural expression just as music, even if we are not able to write music, or we don't know the name of the opera, or et cetera, we don't play an instrument. But when we shower, we sing. I don't see that happening in the same way. There is no comparison with any kind of personal expression regarding science and that. So it's not a surprise for me that actually we have to be a little bit modest about that. There are 104,000 museums in the world, according to the UNESCO numbers. There are less than 3,000 science centers. So the impact of institutions on culture is still extremely limited. And so these are what I think some of the subjective obstacles, but there are also objective obstacles, and some of you have said something about that. And I think that if you want to be part of culture, if you want science to be part of culture, then you have to accept the rules of what that means. And that means mostly being transparent and accessible by everybody, and accept control and criticism. And what do we see? Instead, it's not happening necessarily like that. And some of that is, and it's been said before, science is difficult. And the difficulty of science makes it very difficult to make it accessible to the most people. So it's not like when math is difficult, you cannot just invent some math. When you cannot sing, you can still sing in the shower. So that is the difficulty of science is one obstacle. The hyper-specialization is an obstacle.
Mr. Walter, yeah, you can summarize, please.
Oh, really? Okay. Okay, let me say. So
we have time. We have time. You can go ahead. Yeah.
Okay. So actually, we have a big trend in the scientific community that says there's a need for advocating for science-based decision-making. But what is actually happening, and is something that we all support, of course, and that's been said before, and the pandemic shows that. But what we are actually looking at, what the strategy of the scientific community is to create connections between the world of science and the decision makers, and that does not include the public. And so there is a real gap here, so that this new trend of making science as basis from decision making that address all the topics that concern our as citizens do not include the public at this point. And so there is a need for a triangle where scientists and authorities include the public in the conversation that has been said before about what that means to make decisions based on science. I also think that an obstacle is that controversies, as we see with the pandemic now, are not necessarily well handled. See how complex the scientific method is, and Per spoke about that. And the reality is that we see large groups of people who refuse vaccination, and even health workers who are supposed to help with that refuse the vaccine. We see science being supporting undemocratic activities. I just think about the way that technology is used in China to control the population and give them points about their social behavior. And so that's a way where science actually directly acts against democracy. And science acts sometimes against culture directly, or there is a conflict between science and culture when you try to impose a number of programs to clean water in certain parts of Africa. Because of the traditions they have and the beliefs they have, they will not drink water that's been tampered with someone else. So there is a conflict between science and culture from time to time. And so my extreme, and that is my last example, the extreme example for me is the way that the marches for science have been organized over the last years. The March for Science was a reaction to the expected attacks from the Trump administration to scientific practice. And with reason, we should respond to that. But that attack on science was not the only one. It was part of a very large effort from the Trump administration to defund Planned Parenthood, to take away gay rights, to stimulate again white supremacy, to not address systematic racism and all of that. The Masters of Science have not been able to combine these things, and they have been seen as isolated from the rest of the population. And this was, from my point of view, a very big mistake. If you cannot associate your own struggle with that of other people in the society, there is no way that you're going to actually influence them and create a new culture of science. So what is the answer? The answer is not to do more of what we do now. The answer is to be humble, and how would I say, to become invisible, to dilute science in culture, to invade or transform into community centers addressing well-being and the problems that the community have. We have to start from what the questions are that the people have in the society, and how can we address them, and how can we address them in a multi-dimensional way, and by distillating science into the answer, by giving the people the air to breathe. Thank you.
Thank you, Walter, for such a viewpoint on the culture of science. Now I will have the next panelist to speak on is Suhas B. Naik, who's a planetarium specialist from Mumbai, and he has created a number of planetarium programs and worked for the planetarium for over 35 years. And he has arranged over 500 lectures on enhancing public understanding of astronomy through scientists in his planetarium. And he is a member of the Astronomical Society of India, Indian Physics Association, Bombay Association for Science Education, National Center for Science Communicators, and Indian Science Writers Association, and International Planetarium Society. And he is in social sector. He has been president of the Rotary Club, and also became their scientific literacy committee chairman for 2 years. So I request Suhas to give his viewpoint on the theme, as well as what he thinks has been the real outcome and impact of his planetarium on the society. Suhas, please.
Oh, can you hear me?
Yes.
Oh, thank you, Chairman Rautelaji, for your kind words. In fact, I don't know where to start now, in fact, because you put me in such an orbit that's very difficult for me to remain in the orbit. But I have no choice. But the today's program is, dedicated to Dian of Vishnu Pitama in museum culture is none other than Sarojini, in fact. Like, he completed 87 yesterday, so today he's 87 plus 1, in fact. Like, I think we compliment him for that, because he's one who is responsible for getting 40 beautiful minds together, in fact. I think we would have, if the program would have extended for under one more day, then we would have definitely got another 40 people. So 87 would have definitely matched altogether. When you talk about the scientific culture or something like that, I like to just, in fact, like going around the Nehru Science Center, I happen to got one excellent quotation by none other than our first Prime Minister of India. Why I'm trying to quote over here? Because this year we are celebrating a platinum jubilee. Means we are celebration of 87th birthday of Sarojini, then 75th birthday of Indian independence. So this particular thing, quotation, exactly, like I like to read it. In fact, please allow me to do so. Am I audible? I quote, in quote?
Yes, you are audible, sir.
Okay.
You are audible, sir.
Thank you, sir. In formative period of childhood on the youth, it is essential that people should come to museum and team. Their mind will be different by the direct such they are be there. I would like this aspect of the education to the museum to be enveloped by Panditji, unquote. I'm talking about the planetarium with the permission of Sherman, because the panel discussion where I'm participating is entitled Museum, Science Center, and I'd like to add planetarium in promoting culture of science, in fact, well, we are cultured people. I must tell you something about way back in 1977 when this planetarium, Nehru Planetarium, came into existence. And while inaugurating the planetarium, Indiraji, then Prime Minister of India, said in fact, like, visit to the planetarium is very going to be essential because you are going to change your outlook or something like that. I don't know about others, but when I visited planetarium for the first time, I changed my outlook. And that's the reason I'm here in this field for the last 38 years, in fact, right? Again, way back in 1980, there was a total solar eclipse, which is visible from India. Bombay, it was a partial eclipse, in fact. I don't know how many people remember that incident. When I was in Bombay and I was walking on the highway, Western Express Highway, not a single soul was, looking up in the sky. Thanks to the Doordarshan during that time, everybody was glued because of the film they choose called Milli. In fact, where the telescope is there, and everybody knows the history of Milli, in fact, like. That was 1980. Let's go to 1995. There was another total solar eclipse visible from India, in fact. Again, in Bombay, it was a partial, in fact, It's early morning sky. And I must tell you, in 1980, none of them were visible, none of them were available at the planetarium. But 1995, early morning, more than 100 people gathered at odd hour kind of thing, 6 o'clock in the morning. Can you imagine? People are gathering at the planetarium. In 1990, another eclipse was there, in fact, like you know very well, the solar eclipse takes place on a new moon day. That's called Amavasya, in fact, And Amavasya, people consider, you're not supposed to get out of the day. But what happened on that day? The people gathered at the planetarium, and you can see the number goes on increasing, in fact. Like. And 1990 goes to another 2005 and 2010, recently 2019. And why I'm trying to give this particular example to you, as the time advances, the number of people coming to the planetarium to see the celestial events goes increasing or something like that. And I must tell you that the people who are present there, the communities are nothing no other than the school-going children. The curiosity of this science is generated by the planetarium. These people like to enjoy it through coming to the planetarium. And people say, in fact, like, if you want to become a Galileo, you have to see through the telescope itself, in fact, like. And well, we have a lot of programs, in fact, like, if I can tell you the statistic, something about 1 lakh and more people visit every year to the planetarium. And amongst them, 65% population is of students community. In fact, that I must tell you, the planetarium is nurturing, like encouraging the young minds or something like that. And you happen to see this planetarium culture is increasing in India. And thanks to the National Council for Science Museum, they started with the museum, they started the science center, and now they have the planetarium. I think I can tell you we have more than 50 planetariums. The biggest stakeholder are National Council for Science Museum. If I allow my imagination, in fact, the scientific culture started in West Bengal or something like that. See the amount of scientific museum, scientific centers are there spread in the north, in the east, and try to go to the north. In fact, like you will see the cultural heritage. The people are near the eastern region are, I think, more culture kind of thing. That implies that the culturality can be determined by number of science centers, number of planetariums, and number of museums they have, in fact. And you see the distribution, in fact. And if you start going up, you come to the south, you come to north, okay, see the number of planetariums, it goes on decreasing, something like that. You can come to the conclusion yourself, in fact. See, as such, in fact, you are said about scientific culture. What is scientific culture? In fact, I must tell you the history. Go back in 1956, we have a term called scientific temper. Where are the scientific temper now? And what do you expect the scientific culture to grow in India? But must tell you, if you want to listen, I am not still able to understand what is scientific culture or something like that. So that's the reason National Center for Science Communicator had decided to have one session, one conference dedicated to the scientific culture, in fact, and that goes because of, if you happen to see a TV serial called Cosmos, the person responsible for launching the Cosmos, everybody knows Carl Sagan. Way back in 1978, he did it, in fact, like 13 episodes. And what is it now, in fact, like? Entire Cosmos is in your fingertips kind of thing, in fact, like. I involved in making the planetarium shows kind of thing, in fact, like. The show lasts for 45 minutes, but when you enter the planetarium and come out of the thing, you're enriched with a lot of experience. What happens in universe, which is people talks about 13.8 billion years ago. So we can start what happens, and we can come where we stand now. I can cite example, in fact, like if you have to tickle the youngest mind interest in science and technology, I think planetarium have played a major role, in fact, like. I can cite my own example in my introduction, thanks to Rautila, that highlighted that thing. I was in my 35 years in career in science and in planetarium. I could hold something out more than 500 lectures. These are public lectures. And who are the people who attended the public lecture? This public lecture was attended by mostly school-going children, then science, college-going students, and other people interested in science. I can cite you. In fact, I am not completed my PhD, but I can tell you more than 100 students are pursuing their higher education, are completed their higher education in astronomy, astrophysics, thanks to the planetarium, in fact, like. I can go on and on, but I don't have that big drum where I can beat it, in fact, like. But I must tell you, those who are not visited the planetarium must visit the planetarium, and they can experience themselves. Thanks to the earlier technology, the planetarium technology is going to complete something about 100 years of its existence. You know very well that 1926, the first planetarium came up in Germany. What was that? That was the optical planetarium. The stars were shining during the daytime. Okay, you don't have to, in fact, like, moment you go inside this thing, at the tip of your finger, in a finger, you can change the entire universe, in fact. That's the technology what we are. Now we advance in science and technology. We have digital planetarium. But I am like a conservative person. I like to go back and enjoy the show in the optomechanical planetariums kind of thing, in fact, like. It does give a different scenario, you're in fact, like, I don't know amongst you how many people are seeing the night sky filled with 100 billion stars. But I had experienced myself and witnessed to this particular thing. Moment our stars become alive inside this dome, you start getting a collapse. Oh wow, that's kind of thing. You know, that's, I know, sir, I know, because
Okay.
I cannot.
Thank you.
So I know that's precisely the thing. In fact, like in 45 minutes, you know, with a moderate ticket of 100 rupees, you can have 100 hours kind of thing of excitement. In fact, like friends, that's the way I must visit. I must admit here the last thing that this planetarium is just across to me. I've not seen the entire gallery. In fact, the fault lies with me, not with the center. In fact, like, but I think whenever I come across here, I see the amount of people going here and there, and particularly in the open ground, exciting things happening over here. In fact, like, and thanks to the culture, we should develop under the guidance of Sarojini. In fact, like, friends, can I stop here with your permission? Thank you so much.
Thank you so much, Suhas, for giving the perspective of planetarium in developing scientific culture. Now we have the last panelist, Mr. Samrendra Kumar, who is the director of the National Council of Science Museums headquarters in Kolkata. Samrendra is presently working as the director of the NCSM headquarters, has 31 years of experience in the field of science communication. He joined as curator at the Nehru Science Center, Mumbai, and also worked as the head of the Kurukshetra Panorama and later the Science City, Lucknow. And he is involved setting up the innovation hubs in science centers and implementation of the scheme called Promotion of Culture of Science, which is the major scheme the government of India launched for setting up of science centers across the country. He is also involved with development of galleries, exhibitions, and for NCSM and other organizations. Recently, he has been instrumental in developing international collaborative exhibitions like Superbugs, the end of antibiotics, in collaboration with SMG London, and now working on another international exhibition in collaboration with London Science Museum, the hunt for vaccines. He also presented papers in a number of international and national conferences. May I now request Mr. Samrendra Kumar, who was instrumental in piloting a study called Impact Study of Science Centers through an external agency in NCSM. So, Mr. Kumar, please give your perspective on culture of science, and what do you think about the outcome of the impact study of NCSM?
Thank you,
Mr. Kumar.
Yeah, thank you, Mr. Adela, sir, for this kind introduction. And I'm really privileged to be in such a galaxy of panelists who are leaders in their own field. So I'm just going to talk about especially the government policies and some of the schemes which are in the direction of promoting a culture of science in the country. So I also listened to Dr. Pele that the science should be open and critical debate, should be open to criticism and debate. And I fully agree with him, because the originality and independence of thought and dissent are the characteristic of the scientific culture, and therefore is a challenge to the established cultural values. So I think every speaker has talked about that science and culture and how they are linked. And I think they are totally interlinked, and science is a part of culture, and how science is done largely depends on the culture in which it is practiced. So although there is no language of science, which is, though it is specialized and therefore sometimes inaccessible to non-specialists and common people. So there is there is a lot of dependency on such kind of informal science institutions to make science accessible to the people. So science is also often described as a product of culture. At one hand, science is considered as a comprehension of natural laws, while technology, on the other hand, is the application of scientific knowledge in creating products or tools that improves lives of people. And the culture provides a social platform and shared values that bring and keep people together. But no one can deny the fact that the success of science and the use of scientific knowledge have profoundly changed everyday life, and which is more pronounced in developed countries. Life expectancy has increased strikingly, and cures are available for many diseases. Mr. Rautela talked about the COVID-19 vaccine. I think the culture of science was an important part of that, how we have met that mitigation. The agriculture productivity has increased to match demographic developments, and the technology has freed humankind from arduous labor. There are new methods of communication, information handling, and computation that have brought unprecedented opportunities and challenges too. These innumerable discoveries or inventions by the mankind have radically changed our way of describing the natural world and have influenced our everyday life. So, in fact, the government of India, the successive science policies have therefore emphasized the need of population on awareness of science and technology and creation of infrastructure for activity-based learning for the masses, especially the young generation. There is a need to broaden the knowledge base of the people on science, technology, and the current global issues for sustainable development of the society and consider decision making. If any country has to progress in the knowledge economy era, it has to develop an innovative society through creation of facilities for engagement, creativity, and innovation. There is also a need to have an adequate level of awareness of science and technology in society. Countries like India, where we have a very large number of youth population, especially we need to develop a culture of innovation and problem-solving skills among the youth to enable them to engineer solutions in food, water, healthcare access, education, and affordable housing, and find environmental friendly energy sources. These solutions, which are important to benefit a large section of society, will be crucial for bridging the widening disparity in the country. A strong innovation ecosystem is very important for creating an innovation society which facilitates the birth of new ideas and also provide platforms for the successful exploitation of these ideas. So development of science cities, science centers, and innovation hubs in different parts of the country under a central sector scheme has been a focus area of the activities of Ministry of Culture, Government of India. Earlier, the scheme was called a Science Cities Scheme, but in 2017, it was rightly named as a scheme for promotion of culture of science, considering the fact that science and culture are so intricately linked and intertwined, and it is difficult to separate them. National Council of Science Museums, an autonomous organization, the Ministry of Culture, is the implementing agency of the scheme to set up science cities, centers, and innovation hubs. And what Mr. Suhas Naik Satam was telling, that this time in 2021, we have now added Digital Planetarium and Space and Astronomy Education Center to the scheme to be set up in different parts of the country to promote astronomy education amongst the people, especially the youth. I would also like to tell that the National Education Policy 2020, which was implemented in the country, is the first education policy of the 21st century that aims to address the many growing developmental imperatives of our country. This policy proposes the revision and revamping of all aspects of the education structure, including regulation and governance, to create a new system that is aligned with the aspirational goals of 21st century education, while building upon India's traditions and value system. As several objectives of the scheme of SPOCS are aligned with the goals of national education policy, the scheme can play an important and active role in national education policy implementation through its activities and programs in the science centers and the innovation hubs, and which can help in a big way in the nation building. So far, we have 25 science centers and museums which are operating under NCSM. 22 new science centers have been handed over to the federal state governments. 13 new science centers, including 3 science cities, are in making, and 5 science centers are approved by the Government of India to be taken up. In addition to this, we have 2 science cities and several science centers and museums which are being operated by the state government, the federal governments in the country. Incidentally, under NCSM, we have developed 37 innovation hubs all across the country, which are functioning and involving about lakhs of students who are engaged in this activity, and to promote a culture of innovation and creativity. Mr. Khened also pointed out that why we should not change this scheme. And over the years, because of the continuation interaction with the stakeholders, we have also gone for the vertical expansion this time. In 2021, there is no limitation of the space. If the space is limited and the space is good, we can go for vertical expansion. So in fact, we can say that I'll just show you some of the things, some of the interesting stories of the innovation hubs, which are, because we are connecting with the lives of the people. I would like to just share some of the slides which are there on the innovation hub. Can you share the slide? Yeah, next. Innovation hubs are promoting innovation, creativity, and engagement in science. Next. Next. Okay. Yeah. So I will not go into detail of the scheme. Next slide. What are the activities are there? The activity, next slide. These are the facilities what we create inside a 300 square meter area. And it consists of a lot of hands-on interaction, the design studio and the idea lab, where people can come and give their idea. And I'll show you some of the examples which are happening. Next. If you take the data of January 2021, actually more than 2,000 students are actually involved in doing some innovative idea projects. More than 6,85,000 people have just participated in the exposure visit to the innovation hubs. So we are trying to create an innovative society all across the country. And this is the status of that. We have 37 functional innovation hubs and 3 are ready for opening, 13 are work in progress. And then we have 8 more, which will be coming up shortly. Next. These are all across the country. We are trying to create innovation hub, which is a very good example of networking through various other institutions. Though we have science centers, but we are also going into some of the informal science institutions which are promoting science education. For example, in Kuppam, we have a science activity center. In Pune, we have activity center. So there we are going, and then we are opening these innovation hubs, where the children are being engaged. Next. These are the completed. Next. Yeah. You can say that by December 2008, we had 15 patents filed by the young students also. So we are trying to promote this kind of patent filing and going for the entrepreneurship by the children, because there they are questioning, they are working on different projects which are there. And I would like to share you that because they are closely connected at the local level with the society, they are trying to find out the problems in the society, what the people are facing the problems, and then they're trying to solve those problems through innovative ideas. So next slide. This is one example that one of the patent was this energy-free food preserver. So this has been done in Calcutta, where a young student has done this kind of thing, and he has got this patent. Next slide. This is again an example of how the people are connected with the lives. This is a foot-operated manual page turning machine in Guwahati, in the northeast region of India, and he saw some of the physically challenged people, and then he developed this kind of machine, which was awarded by the then president award. Yeah, next slide. This is another foot operating tea making table for especially able people. So these are the kind of examples how we are connecting the lives, and probably where there is an example where the science and culture, and because culture is connected with the lives of the people, we are connecting the science and the innovation hubs and the science centers. Next slide.
Kumar, sir,
next slide. Yeah. We are just closing. This is another example, a quick finger duster for the whiteboard, where again a student got the national award for this. Next slide. Yeah, next slide. These are some of the examples of young students coming forward, because if you have to build a society, probably we need to engage the students at the very ground level, and they are from the rural background, they are from the very hinterland people. So I think we are connecting those kind of children and trying to build a society. Next, we can go for that. So the activities of the science centers and museums and innovation hubs are designed to promote a culture of science, creativity, and innovation in the country, with a special focus on the youth population. And we are also giving a special emphasis to promote STEM education in girl children in such centers. Yeah, these are some of the activities. Thank you very much for giving me this time. Yeah, thank you, sir.
Thank you, Mr. Kumar, for your deliberations. And you nicely explained how you are trying to create through the innovation hubs, an innovative society. Now we have a few minutes, about 10 minutes, to sum up and have your quick comments. May I now request Edvin Persson, if he is around there, to touch upon developing a culture of science be one of the major objectives of science centers? If it is so, then how can it be done? Edvin Persson, please. If not, I don't think he's around.
I am.
You are there. You are there.
I have been listening with great interest to all the panelists so far.
Oh.
I think I would like to thank you for well thought presentations. The tasks you give me, Ganga, is a little bit how should I say? It's difficult to achieve in something like 2 minutes. I am, as I said, optimistic that when it comes to talking about basic science, and when it comes to things like making people interested in science and increasing the motivation and also perhaps influencing the attitudes, I think those are things that we can fairly easily do with the activities that we do now. But I am actually echoing Walter Staveloz when he was saying that there is so much more to it, which is really not there, and where we really need to think about what our role is. I was talking about the problem with the wicked problems of the world, like climate change, and maybe pandemics belong to that, but many other things, big issues belong to that are very complex. And how are we going to deal with that? Because then we are actually having to merge a scientific and a political, economic and social and so on aspect into it. And that makes it much more difficult to deal with the methods that we usually use. So I think there is a challenge to that. And it is also clear that even if we have been successful today in what we do, we are not one of the major players in the world when it comes to influencing people. So maybe those are the kind of questions we have to ask ourselves. How are we going to make our activities more successful in terms of reaching out to new audiences? And I think that's probably one of the key questions here. I think that's about all I can say with this very short notice and this very short timing. Thank you.
Thank you very much. Sherman, you mentioned about the basic values of science and towards developing a culture of science through questioning, curiosity, honesty, openness, etc. That how do you think the science centers could direct their activities towards achieving these basic parameters of culture of science?
Well, I think the best way of doing it is by example. And I think that the programs that science centers have should be analyzed with those values in mind. I think that there are many good examples, and there are probably some not so good examples, but I think we need to have a criteria. I just threw that out as a possibility because I've been thinking a lot about what makes a good science culture. And I think those that's where I would start with values. So I would use those. I think we'd start off maybe with the staff to think about it, to do some self-reflection, and then maybe even to have focus groups coming in and asking them what they think.
Okay. Thank you. Mr. Walter, you...
सील करके उसी के साथ में
शर्मा जी कहाँ से आ गया यार बीच में?
Sorry.
Walter, I have a question for you to elaborate on. You mentioned that the science has to be part of a culture. You know, in India, I think it's the only country is enshrined its constitution of developing scientific temper in society. Scientific temper is nothing but an attitude of science. And even that's a rule. You said there has to be a rule for developing the culture of science. And science has to be part of the culture. So what are the rules that you mentioned and how can we achieve this?
Yes, thank you. I know, and from what we hear, India certainly is doing much more than many countries in the world to achieve scientific literacy from the population in general and scientific culture. So there is no doubt. India takes it on the government level with a lot of initiatives. I totally agree on that. I think I say basically two things. And that is not focused on India, it's focused on the global, right? Is that we have to base ourselves on data when we do science. We have to base ourselves on data as well about how strong we are and how important we are, and be a little bit humble and realize that despite all the efforts that we have done, we have not moved the needle in the society about making science a bigger place in the collective conscience of the population. That's what I'm saying. And we can give individual examples, and this person has become a Nobel and all of that. We know that. But when we look at the globality of society, and culture is about globality, it's about numbers, it's about everybody in the country. And when we look at that, we are nowhere near what we need to achieve. That's one thing. And the second thing that I say is to get there and to be able, we see that with so many obstacles to actually penetrate the mind of the people with that and increase that consciousness, that we need to find different ways than what we are. It's not multiplying the programs, it's find other ways to reach the people. And the first of that would be go where they are and listen to the problems that they have and find ways to bring science into the conversation on how to solve the problems that keep them awake at night. That is the thing. And so these are the two ideas that I have. And every country is going to address that in a different way. But certainly it's not by staying on saying we do the right thing. We have to really think to innovative ways of penetrating the minds of people. And it's going to be by going to them where they are, listen to what their problems are, what they want to be solved, and then distillate science into that. So that I would say even like not without noticing it, that they're going to actually accept it and become more open to science.
One more quick clarification from you. You mentioned that specialization is a barrier in developing culture of science. So how do you think this barrier could be broken?
Oh, well, certainly there is. I think one way, let me make a very shortcut here. And actually India does that very well as well, if I know from practice. There is a big framework now, which is the United Nations Sustainable Development Goals, that addresses how the planet should move forward to make sure that we are a sustainable, create a sustainable planet. This is the only and the most recognized common platform to understand how the different connections between the global threats to the planet are appearing, and how education can help to address them, how technology can help to address them, how innovation can help to address them. So from my point of view, the strategy for science centers moving forward is to think in a way of how can our programs actually be part of this bigger initiative. And I think that the UN would be very pleased with a large movement from science centers to support the United Nations Sustainable Development Goals, because it addresses all the sciences, because you need all the sciences and the interdisciplinary approach of sciences to address any of the sustainable goals that are in there. And so I think that that would be a major step forward if we all collectively together would work on that.
Thank you. Mr. Kumar, one clarification. You mentioned about the scheme for developing culture of science. You develop various science centers in the country. Your recent evaluation study, the impact study you carried out, do you think there are indicators in the study that tell you that your goal of developing scientific culture in society has been achieved to some extent?
Yes, sir. I would like to say that in that impact assessment study, what we did, more than around 28% people felt that, okay, it is serving the cause of that, because there's superstitions and the belief systems are being challenged, and they are getting answers to that. So I think the impact study was very helpful in that. And it also told that it is creating that kind of system, that kind of value in the society. And many people are getting benefited because of the science centers, their activities, and their role in the society. So I think that was very important. And in fact, we also did a third-party evaluation of this scheme, the whole scheme as such, by the independent body. And they also felt that all these facilities which are being created, they are really helping the society and trying to bridge the gap between science and culture. And that's why it has been named as a scheme for promotion of culture of science, and not only science, but the culture of science, because I think it is intertwined with our society. And if we take out the examples, what we are doing in our innovation hubs, there we are trying to link with the people, the daily lives of the people. What Walter has explained, that unless we connect, unless we find the local problems, unless we go to the people, and we cannot solve the problems like that. And we can actually, the science centers can be a kind of bridge between the problems and the solutions also. And if the young generations come forward, probably that will be good for the society and good for the country also. Thank you, sir.
Thank you. Mr. Khened, you talked about the science centers are somewhere working in a silo, and you need to have an integrated approach involving all stakeholders in our activities and programs towards developing a scientific culture in the country or elsewhere, wherever we talk about. So would you like to elaborate a little on this? How do we, what are your stakeholders who should be involved in developing the culture of science to have an integrated approach to our science center work?
Thank you so much. At the outset, we are living in what we call the 21st century with kids. They all talk about acronyms. There is an acronym known as soon as possible, ASAP. It's something which every one of us use. I feel particularly that we need to have this ASAP embedded in all the scientific institutions in India. What that ASAP, as far as I'm concerned, it's called as augmenting science awareness in public. Now, what is happening is, first and foremost, what Dr. Ghosh talked about, we were a part of science CSIR, and there we were not a priority. So there was a task force which detached us from the CSIR to form a NCSM. Right now we are in culture. Do we really need a policy thinking to change from science to culture to science or somewhere else? And in this case, if you really look at the Human Genome Project, what they did is they invested about 3% of the funding on ethical, legal, social issues. In a similar manner, can we have a cell known as ASAP in every scientific institution, including in the science museums, where whatever projects are there, can we have 2 or 3% of the budget in which we have a dedicated team of people, social scientists, NGOs, political scientists, scientists per se, science communicators, everybody put together, producing enormous amount of scientific content which can go to the people. Because, it's a tyranny of numbers. We are dealing with 1.3 billion people. Trying to talk about scientific culture among 1.3 billion people, perhaps it could be an utopian concept. But then if you really look at vaccine hesitancy in India is much less than most of the countries, primarily because there is something known as the ASHA workers, who are the foot soldiers who are going to every nook and corner of the country. That's the reason our health infrastructure, although it is very poor, because of this last mile connectivity that is being handled by these ASHA workers. Can we really create kind of an ASHA workers for taking science or creating a scientific culture? These are the issues which we need to address. And for that, we need a funding, mandatorily a policy-based funding. In fact, from the National Center for Science Communicator, this has gone as a comment on the STIP policy 2020. Can this be done? So this is my way of thinking, because it's a utopian thing to consider that, scientific culture in 1.3 billion people. But yes, it's always, we need to have very high aims. Thank you.
Thank you very much. My last question, because we are short of time, to Mr. Suhas. You mentioned about how the perception of people about solar eclipse changed from 1980 to 2010, that they didn't come out of their houses in 1980, but came out in large numbers to view the solar eclipse in the planetarium. Do you think this kind of eradication of their beliefs that solar eclipse is harmful to society or to people is changing to a large extent, or it is only just small numbers that people are adopting?
Oh, you want my direct answer to this question is, in fact, if you have to say number is increasing. And what you have the Rahu and Ketu is no more the part of the syllabus as far as the new young generation is concerned, in fact, You don't have to worry about them, in fact, at all. And I must tell you, in fact, why the eclipse, any celestial phenomena for that matter, the excitement generated is of beyond kind of thing, in fact, One has to come to the planetarium, one has to come to science center to see the excitement, what is happening in the sky. Just small thing, in fact, like the phenomena called as the occultation. The one star is eclipsed by the moon or something like that. That also people start enjoying through the telescope. And thanks to the ingenuity shown by the planetariums and the science center, people start coming to, in fact, like see this. I can cite the example of the apparition of the Mars. Mars is coming closer to the Earth. People thought either coming closer to the Earth is going to look like a moon. Oh, that is the reason, in fact, in fact, thanks to media also, sometimes they play a very different role altogether, in fact. Mars is coming closer and closer. It's not going to look like a moon, but people will say, oh my God, that's going to happen. Why not go and see through the telescope? With the naked eye, Mars appears to be red in color, but if you have a telescope, the telescope will try to show you the very greatness of the Mars differently, in fact. That I said to you, in fact, thanks to the advent of scientific culture, to the planetarium, to the science center, to the museum. Now the people, whatever the blind faith what you accepted earlier is no more there kind of thing, in fact. People like to drink, a glass of water when the eclipse is taking place, kind of thing. It's not I'm not going something like that, but the word superstition, you don't have to take into account any more kind of thing, in fact. That's the excitement of science, in fact. And that is our planetariums, science center, again, I'm repeating, played a major role. I don't want to use eradicating them. There is no eradication is possible, can there? That only possible with the induction of gamma rays kind of thing on onion and potatoes kind of thing. But is this, I think I'm very happy about what is happening. So in 20 years down the line, in fact, when India is going to celebrate our century, in fact, in 2047, you have a different mindset of people together, in fact.
Thank you very much, Suhas. While I thank all the panelists for their excellent deliberations on the theme of the conference and the particular session, there are many questions remain unanswered. For example, how to synergize between culture and science, and how to approach cultural aspect into science communication, and what science centers and planetariums can do to develop a scientific culture, and what we have achieved so far. So I would like to thank all my panelists for their wonderful presentation and for the time they gave to this session. And thank you very much. And we hope to continue our collaboration on developing scientific culture.